Hello again. In this video, we're going to go over derivatives of sine and cosine. I'm going to show you a lot of information just as to how the derivative of sine is cosine x. I'm going to show you a lot of information on how the derivative of cosine is negative sine. We'll do a few practice problems, but a lot of this information is just information for you. You most likely will not be tested on it. Okay, so this is page 17 in your packet. You should go there. It says, you know what the derivative of y equals sine x is and y equals cosine x is. I didn't tell you before, but if you ever feel like you need to pause the video because I'm just flying through things, you should make sure that you do that. Okay, we're going to look at the graphs of each derivative, and then we're going to use the difference quotient. We're going to use the difference quotient to derive each one, and we're going to need a little trigonometric knowledge to prove this. So first of all, you already know what the derivative of sine x is. Just write it in there. Oh my gosh, Mr. Lakin. I want an extra credit point. You almost made a mistake. But I caught myself. No extra credit. So the derivative of sine is cosine. We're going to, not you, I am going to go to Desmos, and I'm going to graph a few things here. I'm going to go back and forth between the two. So first of all, if I go to Desmos, yep, there it is. So here is sine x. Ooh, wow. Very pretty. Okay, now for sine x, this is the graph of sine x. I'm going to go and plot it on my other one. So let me go back here, and let's go and plot some points here. I got 0, 0. At pi over 2, sine is at 1. At pi, I'm at 0. At 3 pi over 2, I'm at negative 1. And at 2 pi, I'm at 0 again. Oh my gosh. And similar happens here. And again, it's a beautiful drawing. Don't knock it. It's great. So this is a graphic derivation by Desmos. Now I forgot I actually had an extra slide for this, so you can feel free to fast forward the video here while I'm just plotting everything again in a much neater fashion. If you fast forwarded already, you probably didn't hear any of this part. If you didn't fast forward the video, you probably are still listening to my dying voice. It's dying. Slowly but surely, it's dying. And wow. Whoa. That was actually better than the last one, if you paid attention. That was really good for you. Okay, I'm going to find values. So you should be listening now. I'm going to find values of f prime of 0. And remember, f of x is sine x. I'm going to find f prime of 0. I'm going to find f prime of pi over 2 with Desmos. I'm not doing it by hand. I'm doing it with Desmos. F prime of pi over 2. I'm going to find f prime of pi. I'm going to find f prime of 3 pi over 2. And I'm going to find f prime of 2 pi. Now, if you already know what those values are, go for it, man. Go ahead and just start plotting them. But if you don't know what those are, like me, I have no idea what those values are, then please pay attention. Okay, so f prime of 0 is 1. F prime of, and again, please make sure you're writing this in your in your packet. F prime of pi over 2 is 0. F prime of pi is negative 1. F prime of 3 pi over 2 is 0. And f prime of 2 pi is 1. Okay, so let's go ahead and plot those. Again, you should have written those down already. So f prime of 0 is 1. F prime of pi over 2, oh gosh, is 0. And f prime of 3 pi over 2 is 0. Oh, I messed up. Don't worry. I got it. Okay, I think that's correct. Yes, it is. So let's plot those. So now we have 0, 1, which is up here. We have pi over 2 and 0, which is here. We have pi and 1. Sorry, pi and negative 1. Ooh, almost messed up. So pi, we have negative 1. Then at 3 pi over 2, we have 0. At 2 pi, we have 1. Hey, this looks familiar to me. This looks familiar to me. This doesn't look like sine of x. This looks like cosine x. Let's see. I'm going to plot everything super quickly on Desmos. Again, if I went too fast, rewind, please. All right, let's do this one. Comma. There's that one. There's this one. There's this one. Okay, so we can see that these values, if I take away the sine graph, are plotted here. And we can also see that these values do make that cosine x graph. So let's see if cosine of x is that. Oh my gosh, there's f prime of x. Here's cosine of x in green. It's the exact same one. So this is just a fancy way to do this. I want to bring one more point to your attention. We said that f prime of pi over 2, I'm sorry, f prime of 0 is 1. The reason f prime of 0 is 1, if we zoom in on this line, right by 0, we can see that the slope here is about, let's zoom in a lot. We can kind of see that the slope, well, I don't know if you kind of see it, but this slope is 1 very close to 0. And we could do similarly for other values. So for instance, for like f prime of pi, or pi over 2 rather, we can see at f prime of pi over 2, we do have a horizontal tangent, a slope of 0, which is why f prime of pi over 2 was 0. So that's just some background info on graphing a derivative. And kind of deriving that this derivative is cosine x. You're not ever required to do this, so I just want to show you some background info. Here's something else you're not required to do, is derive the limit definition, derive the derivative for sine of x. Okay, the trig fact for this that you're going to need to know is that sine of x plus h, an angle addition formula, is sine of x cosine of h plus sine of h cosine of x. You're going to need to know that for this problem. Second thing you're going to need to know for this problem. These are special limits that we're going to cover in April. We're going to cover in April because of L'Hopital's rule, so you don't ever actually have to memorize these limits. However, if you would like to memorize these limits, you're more than welcome to. This particular limit is 1. This particular limit is 0. I'm going to show you quickly on Desmos what that looks like. And then we're going to go on just for proof, because I don't want to just give you facts without actually kind of like explaining them slightly, ever so slightly. So going back to Desmos, let's see here. So sine of x over x. Oh, that's not it. So you can see here that again the derivative is the value at the value of 0 is undefined for this function. But if we zoom in a lot, the limit as x approaches 0 is approaching 1 on both sides, a y value of 1 on both sides. So that's why this y value is 1 here. The limit for sine h over h is 1. And for the other one, similarly. So here is this graph of cosine of x minus 1 over x. And you can see the y value on both sides is approaching 0. And if I drag the cursor, it does give me an undefined value at x equals 0. But the limit is 0. Two special limits. That's all I wanted to show you. Let's derive this. And again, you will never have to do this, ever again. The derivative of sine x is going to be equal to the limit as h approaches 0 of sine of x plus h minus sine of x all divided by h. This is the derivative formula for sine of x. Remember, d dx means take the derivative of sine x. We're using a limit. After this, you'll never have to do that again. I would just sit back and watch maybe and write too. Angle addition formula for the sine of x plus h is right here. So let's write that in. We have sine of x cosine of h plus sine of h cosine of x. And then we still have the minus sine x all divided by h. I notice here that I have two sine x's, and that's convenient, so I'm going to take care of those two sine x's by doing the limit as h approaches 0 of sine of x, and I'm going to factor out of both those terms. So I get cosine of h minus 1, that's all divided by h, plus, and I can actually do this with limits, I don't know if you were aware of this, I can break them up, limit as h approaches 0 of cosine of x times sine of h over h, and I'm sorry that that got sloppy there. Okay, next. The next thing I can do is I can actually take the sine x out. Now, if you haven't seen that before, that's confusing. But the reason I can take sine x out is because the value for the limit, the variable for the limit is h, not x. So anything that doesn't have the matching variable for the limit gets to go in front of the limit. So sine x comes out, and everything else inside stays the same. So the limit as h approaches 0, cosine of h minus 1 over h stays there. That's for the first part. Plus, looking at the second part, the limit as h approaches 0, but I can actually take something out here, so let me take that out. I can take out the cosine x. So plus cosine x times the limit as h approaches 0 of sine of h over h was left over. And I get sine x times the limit as h approaches 0 of this one is 0. It's right here. So that's 0. Plus cosine x times the limit, this limit is 1. Well, that just leaves me with cosine x. And this is a limit definition of how the derivative of sine of x is equal to cosine x. So what we just proved is d dx of sine of x equals cosine of x. You never have to do that again, ever. It will never be asked of you on a test. In this class, you never have to be asked it. It won't even be asked on an AP test. Okay, let's go to the next one. That was fun. That was super fun. I like that stuff. Can I do a smiley face? Let me do a smiley face. But I gotta get going, though. I gotta get going. I have to hurry. Yay! Next. Derivative of cosine x. Well, that's negative sine x. Okay, if we graphed cosine x, just like we did the last one, and again, you're not going to be asked to do this. I just want to give you this extra information. We get a value of pi over 2. Cosine of pi is 0. Cosine of 3 pi over 2 is negative, this is pi over 2. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Almost messed up again. Cosine of 3 pi over 2, that's 0. Cosine of 2 pi, that's 1. So we get this looking graph. Okay, so the derivation of it, if I do f prime of pi over 2, f prime of 0 and f prime of pi over 2, and f prime of pi, and f prime of 3 pi over 2. Well, I could take a long time and tell you what that is, but I'll just use decimals. So it looks like for 0 is 1, and then for, let's take out this one. Okay, so 0 is 0, pi over 2 is negative 1, at pi is 0, at 3 pi over 2 is 1, and at 2 pi is 0. Again, please pause the video if that went too fast for you. 0 is 0. At pi over 2, the slope is negative 1. At pi, this slope is 0. At 3 pi over 2, that slope is 1. And at 2 pi, we're back at 0 again. So if we plot these values, we have 0, 0. We have pi over 2 and negative 1. Pi is 0. 3 pi over 2 is 1. And 2 pi is 0. This is a 1 and this is a negative 1. Well, that looks like sine of x. But it looks like it was flipped around. So if we went back to Desmos, and again, you're welcome to pause if I'm going too fast. If you went back to Desmos, you would see that these graphs match the points that we were given for the derivative. And again, this is going to be negative sine x. There's a derivative here. Okay. Deriving it. Now I messed up again. Okay, deriving it. Now, Ms. Schwartz is going to be mad at me because these videos are supposed to be 15 minutes or less. Now you guys might be mad at me. Okay, it's cosine of x plus h is equal cosine x, cosine h. This is an angle addition formula, minus sine of x, sine of h, and now I'm going to go super fast. This limit was 1. We said that in the last one. This limit was 0. And you don't have to write that down now. You can just follow along here. So the derivative of cosine x is going to be limit as h approaches 0 of cosine of x plus h minus cosine of x, all divided by h. Angle addition here, so I can keep going. The limit as h approaches 0. Let's get this a little bit neater here. Of cosine of x, cosine of h, minus sine x, sine h, minus cosine x, all divided by h. Okay, I can take out a cosine x from 2 terms. So I'm going to go ahead and do that for a cosine x on 2 terms. And I'm going to get, and again, a cosine x, well, I'll just rewrite here. So the limit as h approaches 0, cosine of x, and now there's left over cosine of h minus 1, and it's all divided by h. And then we have next, we have plus the limit as h approaches 0 of the rest, sine of x times sine of h over h. One thing I glossed over in both parts is that when I plugged in 0 at the beginning, I did get 0 over 0 out. I should have said that in the other problem as well. I do get 0 over 0 out, which is why I'm going through this lengthy process of solving the limit. Okay, let's keep going. So now I can take the cosine x out because I have x's here. My limit requires h's, so I can take anything with an x out. So I have limit cosine of x, limit is h approaches 0 of cosine of h minus 1 over h. Then we have plus. We can take out the sine x. And it should be a minus sine x, so let me just make that little note here. So it should be a minus, not a plus. Minus sine x. And then it's going to be times the limit as h approaches 0 of sine of h over h. Okay, we can get our final answer now. Equals cosine x times 0 minus sine x times 1, because that's the respective values in the limits, which is equal to negative sine x, and that's what we wanted. We wanted the derivative of cosine x to be equal to negative sine x. If I went too fast for you, please pause the video, resume when you're ready to catch up. Here's the problems, because these are the most important. This is a constant multiple rule, which means the 5 ain't doing nothing. Yes, I said ain't, so we put a 5. Derivative of cosine x is negative sine x, which means my answer here is negative 5 sine of x. Done. No limits. Absolutely no limits at all. For the last one, we have the derivative of 6x plus sine x. So the derivative of 6x we did before, that's going to be 6. Plus the derivative of sine x is going to be cosine x. And remember, that's the function addition where I can take the derivative of both parts. And that is my answer. And I believe that is it. Okay, guys, thank you for, one last thing. Final note on derivative notation. You can express derivatives as d dx. You can say f prime. So this is called Leibniz notation. This is called prime notation. You may also see dy dx. And you may see f prime of x. d dx is only used when you're telling somebody you are going to take the derivative. And then f prime, and dy dx, we'll go over those parts afterward. And I believe that is about it. Thank you for watching, guys.